internet connectivity, so we started late. I was probably so it's 9 minutes late, so I'll go over 9 minutes for this live stream as well. So welcome to OneClass. This is Chang, one of your senior tutors. Today we're going to talk about some math problems that ranges from university level to high school to middle school, and we'll start from the hardest problem and go through to the less difficult problems. So let's get started. Cool. Oopsie. So let's look at our first problem. Our first problem is asking us to convert the decimal 0.22222. The dash line on top of the number just means that it goes infinitely. So like it's actually 0.2 is actually 0.22222, and the 2 goes infinitely. And we want to convert this decimal to a fraction by writing it as an infinite series. So looking at this number, we know that is by like the infinite series, we actually write it as a infinite geometric series. So what are geometric series? Geometric series, or like, I guess geometric series, they're just, they're in the form of, or actually let's just directly write the sum of the geometric series. So Sn is referred to the sum of the geometric series, and usually they are just A1, and A1 is the first term of the geometric series, and 1 minus Rn. R is the difference between two consecutive terms, or not the difference, it's the next term in the geometric series divided by the previous term in the geometric series. So it's actually multiplication instead of subtraction. So this is the sum of a geometric series. So in order to find this sum, we need to find the limit. This is just like knowledge about geometric series. So if you haven't heard of geometric series before, this is what you gotta know. And n tends to infinity. N is just like an arbitrary number representing the nth term of the geometric series. So we want to tends to the limit. So like as n tends to infinity, what is the sum of the geometric series? So basically, when the number of terms of a geometric series is infinite, what is the sum of this geometric series? And that would be the limit of n tends to infinity of this expression over here of A1, 1 minus Rn over 1 minus R. And we know the we can't really find this difference, but we know that when R, or the difference, is smaller than 1, or is between 1 and 0, or when R is a fraction, we know that R to the power of n, when n tends to infinity, is infinitely small because you're multiplying an infinite number of fractions together, so they're arbitrarily small. So we know this term over here, or let me use another color. So this term over here is arbitrarily small. So it's approximately 0 when n tends to infinity. Approximately 0 when n tends to infinity. So 1 minus approximately 0 number is just 1. So we can simplify this expression to A1 times 1, which is just A1, over 1 minus R, where R is the is the next term in the geometric series divide the previous term in the geometric series. And we know where R is between 0 and 1. This is kind of an extra piece of knowledge that we need to know about geometric series. Now, let's write 0.2 in the form of a geometric series. How do we do that? We know 0.2 is actually equals to 0.2 plus 0.02 plus 0.002 plus 0. Or I guess I'll just write it like this, and we know like the idea of it. So from here we know that we can write 0.2 or 0.2 in the form of this, and they are the same. They have the same value. So we know from here the first term of the geometric series is just 0.2. And we know the difference between the next term of the geometric series and the previous term of the geometric series is 0. Or I guess I should write it in fraction form, is 1/10. So 0.2 times 1/10 is 0.02, and 0.02, or I guess the arrow should go the other way. I'll just write it the arrow in the other direction, so it's not as confusing. Oh, 1/10, and 0.02 multiplied by 1/10 is 0.002. So the difference, or the factor between each of the subsequent term in a geometric series, or in this geometric series, is just 1/10. So we know r is equals to 1/10. And let's just write a1 also in fraction form is equals to 2/10, which is equals to 1/5. Okay, so we know the term a1, is 1/5 in this case, and the term r is equals to 1/10. So the sum of this geometric series, or 0.2, is equals to a1 over 1 minus r, which is also equal to 1/5 over y minus 1/10, which is equals to 1/5 over 9/10, which is also equals to 1/5 multiplied by 10/9, which is, you'll simplify it, so the result is 2/9. So in order to write 0.2222 as a fraction using geometric series, this is the process we follow. And we know that 0.2222 has the same value as a fraction 2/9. And let's double check that using a calculator here. Desmos is just a scientific calculator online. I really like it. It's really useful. See? Here we go. We double check our answer, and we know 2/9 is indeed 0.2222. So yeah, this is how we complete this question. And let's look at our sample answer. Yep, they had more explanation of geometric series. I kind of didn't explain geometric series as much, but I explained how to find the sum of the geometric series in more detail. And yep, they did the same thing as us. But they didn't write, they wrote it in the form of geometric series, but they didn't give the fraction. Let me see. Yes, the question asked us to write this decimal in a fraction, but the answer didn't do that. So let's just say needs to write the geometric series into fraction form. Needs to write the generation in a fraction, or needs to convert the geometric series into a fraction. And let's give them a hint. Let's say try to find r by finding the sum of a geometric series. Okay, and the solution is not actually, I guess it's correct, but it's not complete, so let's just say it's incorrect.